topic entitled How is Letter Converted into Binary Form and Back. But first, what is binary? Binary is a numeric system that is comprised of digits 0 and 1. A computer uses these digits to place data within the computer. The digits can represent letters used to convey important messages. For example, 0 means that you have no electrical flow within your computer's hardware system, whereas 1 means that you have enough electrical flow for it to run functionally. Additionally, each binary code must be produced in physical form so it can be properly stored. Why binary is important? Binary code is important because it can use the digits 0 and 1 to solve complex problems regarding the mechanical functions of computers. Binary numbers also make it easier to create designs for computers and make it more cost-effective as well. These numbers have allowed organization to maximize energy output of this system. In addition to working on reliable systems that increase their performance in the workplace.
Letters or character in general are often represented in binary form using character encoding schemes. Two common characters encoding schemes are ASCII, also known American Standard Code for Information Interchange, and Unicode. ASCII encoding. ASCII is a character encoding scheme that represents characters using 7 or 8 bytes. It was originally designed for English characters but has since been extended to include characters from other languages. In ASCII, each character is assigned a unique numerical value between 0 and 127, or 0 to 255. In the extended ASCII version, for example, the letter A is represented as 65 in decimal, which is equivalent to 01000001 in binary. To convert a letter to binary in ASCII encoding, find the decimal ASCII value of letter. Convert that decimal value to binary. To convert binary back to a letter, take the binary representation, convert it back to its decimal equivalent. Find the character associated with that decimal value in ASCII table.
My name is Jay Capuyan. So, Unicode encoding. Unicode is a character encoding scheme that represents a much broader range of character, including those from various script and languages. It uses 16 bytes, 2 bytes or more per character. Each character in Unicode is assigned a unique numeric value. In this value can be represented in binary. To convert a letter to binary in Unicode in encoding, find the Unicode code point for a character. For example, the code point for A is U plus 0041. Convert that code point to binary to convert binary back to a letter. Take the binary representation, convert it back to its decimal equivalent, the unique code point. Find the character associated with a code point in the Unicode standard. Here's an example using the letter A. In ASCII, A is represented as 10000001. In binary, it has a decimal ASCII value of 65. In Unicode, A is represented as 0100000001. 000001. In binary, it has a unique code point of U plus 0041. To convert 01000001 back to A, you would follow the reverse process, converting it to decimal and then looking up the character in the appropriate encoding table.
Why is binary code such a big deal in computers and other computerized devices like calculators, printers, coffee makers, and microwaves? Bits are usually transmitted electronically, but this electronic information is fleeting. For it to exist for any length of time and without a power supply, it must be stored physically within the device's hardware. That means that every piece of binary code in a computer must be converted into physical object or state. Binary code, as it turns out, is easy to convert from electronic information to physical information because only two kinds of physical objects are or state are needed. And let's proceed to the conversion from electrical information to physical information storage is analogous to someone speaking the binary code of dog. Example is dog in 0s and 1s, while you write them on a piece of paper. The spoken 0s and 1s can't be heard indefinitely after they are spoken, but by writing them physically on a piece of paper, you can refer back to them over and over again. In the case of computer, that binary code might be stored in high and low voltages, in magnetized or demagnetized segments of metallic disk, or in super old computers in punch and unpunched holes in card stack.
Hello, I'm Dave Lamoste, and today we'll be giving examples on how to use the ASCII code to convert words to binary, alright, words or letters to binary. So let's start. We have an example here using the ASCII table shown below. Convert the word blue to binary. So before we start, I also want to apologize for the noise because our neighbors are having a blast because of someone's birthday. It's someone's birthday today. So anyways, let's proceed. Okay, we must convert the word blue to binary. Okay, to do that, we must first write a table just like this so that we can identify it clearly. We have here the capital B, L, U, E, and take note that the ASCII code is case sensitive. So yeah, that's the letters, and this table right here, we have the corresponding characters and the ASCII codes, right? So we have here our letter and decimal number of the letter, and we must convert it to binary. So to do that, we must write the binary numbers 1, 2, 4, 8, 16, and 32, and 64, and so on and so forth, multiplied by 2. And here we have the converted decimal to binary, which is 10000010. 64 plus 2 is equal to 66. So let's proceed to the small letter L. So the ASCII code of small letter L is 108. So here's the binary code converted from decimal. So 164 plus 32 plus 8 plus 4 is equal to 108. So just like that, and so on and so forth, and yeah, that's basically how you convert decimal to binary.
Hello everyone, my name is Almojeb Yuson, and I will now explain to you how to convert ASCII code to letters. As you can see here, we have on the right side we have a table of characters along with their ASCII numbers, and then at the top, as you can see, we have our 100100 is what we call Unicode. First step is you'll put the binary number 64, 32, 16, 8, 4, 2, and 1. I already indicated and I will show you how to do it. You'll only add the number that hit by number 1, and that's first is 100110. So the number that hit by 1 is 64, 8, and 4. You will add it. 64 plus 8 plus 4 is equals to 76, and you will find it here in the character. That's a letter L, and the second example here is 11000101. you'll add it, and 64 plus 32 plus 4 plus 1 is equals to 101, and that's a lowercase t. And I have more 3 example here. All you have to do is you'll try it yourselves. That's all. Thank you.